Alright, so question number 7, we're being told to show that sec inverse of 5 over 3 minus sec inverse of 5 over 4 is equal to sec inverse of 25 over 20. So when you look at this number from first step, it actually looks complex, but it's actually a very, very easy number. So how do we solve this? So as usual, we're going to let a to represent one of the values on the left hand side. So we're actually proving this. So let's first convert them into a and b. So this will mean that sec of a is 5 over 3. Then we're also going to let b be equal to sec inverse of 5 over 4, of which it will mean that sec of b is 5 over 4. So now this then becomes a minus b is equal to sec inverse of 25 over 24. So now let's bring this sec to this side. So we'll have sec a minus b is equal to 25 over 4. So now basically what this means is all we have to do is we have to prove that sec of a minus b shall give us 25 over 24. So let's focus on the left hand side. So we know that sec of a minus b shall be is the same as 1 over cos a minus b. Alright, so now the next thing is when we expand cos bracket a minus b with the knowledge of compound angles, we know that it shall give us cos a cos b plus sin a sin b. But now we can easily find what from here we can easily find what cos of a is, and we can easily find what cos of b is, but we need to find a way of finding sine of a and sine of b. So let's look at what I mean. So where we know that sec a is 5 over 3, so that basically means that 1 over cos a is 5 over 3, and then that means cos of a shall be equal to 3 over 5. So now we're going to use this knowledge to find what sine of a is. So we're going to put this in a right angle triangle, and then the angle is a, the adjacent is 3, and the hypotenuse is 5. So now we need to find the opposite, but we shall use Pythagoras theorem. So now a squared plus b squared is c squared, and then it means that 3 squared plus b squared is going to be equal to 5 squared. So when we make b squared the subject, we'll have b squared being equal to 5 squared minus 3 squared, of which b squared shall be the same as 25 minus 29, which is 16. Then we find the square root of 16, which shall be equal to 4. So therefore the opposite is 4. So what this means is that sine of a, of which sine is opposite over hypotenuse, shall be equal to 4 over 5. Now where sec of b is 5 over 4, we know that means that 1 over cos b is 5 over 4. So it means that cos of b is 4 over 5. So now put this in a right angle triangle. We shall use cos of b to find what sine of b is. So the angle is b. It means that the adjacent is 4 and the hypotenuse is 5. So from Pythagoras theorem, a squared plus b squared is c squared. We'll have 4 squared plus b squared being equal to 5 squared. So b squared shall be equal to 5 squared minus 4 squared, of which this is 25 minus 16, which the answer shall be 9. So the square root of 9 is 3. So b shall be equal to 3. So that's what we have. So that means that sine of b, which is opposite over hypotenuse, shall be equal to 3 over 5. So therefore we now have sec of a minus b shall be equal to this. So we'll have 1 over 3 over 5 times 4 over 5 plus 4 over 5 times 3 over 5. So when we multiply those, we have this. So we have 1 over 12 over 25 plus 12 over 25. So we add those two fractions and we'll have 24 over 25. So sec a minus b is 1 over 24 divided by 25, of which that is basically the same as 25 over 24. And then we can now take the sec back to the other side. So we'll have a minus b being equal to sec inverse of 25 over 24. But remember that a represents sec inverse of 5 over 3, and then that b represents sec inverse of 5 over 4. So therefore we have sec inverse of 5 over 3 minus sec inverse of 5 over 4 is equal to sec inverse of 25 over 24, and hence we've proved the number.